Hello guys, today in the lab we're going to study and learn how to use the most important equipment in your career, in your education, and also when you graduate and get a job in this field. It's called the oscilloscope. As we see here, this oscilloscope is from an American brand name called Kenwood. The most famous oscilloscope is Tektronix and HP, but now HP has changed its name for the test equipment to Agilent and maybe some other name. The maximum frequency it can measure is 20 megahertz. This is an old style analog scope, okay? And most of the time it's huge because look how deep it is. It's almost 40 to 50 centimeter. It has a CRT known as cathode ray tube. This is the face of cathode ray tube, and it's a glass tube that goes also probably to 2/3 of the depth of this piece of equipment. The cathode ray tube in the back has an electron beam generator of some kind using anodes or cathodes or shields وما بعرف شو يعني using the tube technology before the transistors. التيوب هني لمبات بنسميهم بالعربي وبقلبهم انود وكاثود وجريل وما بعرف شو، هذه تكنولوجيا قديمه انا ماني دارسها بس سامع فيها لما كنت صغير وعندي شويه بيسكس عنهم. المهم هلا هذا الالكترون بيم they have coils on the back of the tube، بيرفع التيوب ويحطوا عليه coils، وهدول الكويلز في vertical deflection للبيم و horizontal deflection. So what they do is they control where the beam is gonna scan the screen, and it starts on the top left corner and it goes to my right here, and then it goes down and it scans, and it plot by basically scanning, but it turn on the beam only when there's something to be displayed. So the coils deflect the beam, although it's turned off, but when it comes on, when you're ready to display a curve or a signal, then the electron beam is turned on, and then you see here shapes. But when we show one, I'm gonna ask, can you slow down the recording to see it in slow motion while we're recording, or only after you play it? Okay, so when you play this video, you can slow it down when I start showing you signals here, and you will see that it's actually one dot that is moving when you do in slow motion and plotting like a pencil on the face of the screen. This is totally different concept than liquid crystal displays that we call nowadays LEDs, because their backlighting is done by light emitting diodes. In the old days, the LCDs, liquid crystal displays, used to be turned on by fluorescent lights, and they consume more power and more battery. So now with LEDs, they can make the LCDs much thinner. That's why there's LCD TV. But كمان also في all the plasma, and they are cheaper but thicker TVs than LED TVs. This is the power. Every device has a power button, so obviously we turn it on. The most important thing is a lot of people play randomly with these knobs, so after it takes a while to warm up. I'm gonna mess up everything here so that we learn how to, set it up properly, okay? Because a lot of people play with these equipment and you come and you think it's messed up, it's not displaying anything. So what you have to do, first thing, you have to set both of your, I have here 2 channels. Let's talk a little bit about the probes. The probe of the scope is not like a DMM, digital multimeter scope, okay? It has a thin cable, it's a coaxial cable. It has a shield and a center wire that is shielded to prevent noise from being picked up. It has a BNC connector, and this scope also has a switch that makes it, if you look carefully here, there's a ×1 and there's a ×10. Because we're dealing with small voltages below 50 volt, you can stay at ×1, okay? If you are measuring voltages 50 and above, I'd recommend you go to ×10, okay? ×1 will allow you to see smaller millivolt signals, but when you go to ×10, instead of seeing 5 millivolt, you would probably see 50 millivolt. But if we look at this most important knob I start with, of course, the intensity is more important. Let me talk about the intensity. But I have to see my beam. So I set the input of the scope to be ground, okay? Here and here, so that it doesn't receive any signal from the outside. So I can center my horizontal lines when I show them, okay? But I still don't see where my horizontal lines are for each channel. I have 2 channels in this scope. Channel 1 input and channel 2 input. There are more advanced features I'm not going to talk about today. Let's learn the basics. So channel 1 input has this channel 1 controls, okay? It basically, we'll talk about them. Let's play with the intensity, take it to the max, and then you have to move this position, okay? I still don't see a signal. So I'm gonna go here, mode, vertical, channel 1, trigger on auto. I still don't see any signal. So it's hard sometimes, maybe someone played, you see right here, okay, someone played with the horizontal position. This is the dot that I say is supposed to be now walking to the right, and it's not, it's frozen. The main thing is we have to see a horizontal line. Now, I turned off, let's learn this button here. It says times 10 magnification in the horizontal way, because this is horizontal control, yani time control. So I don't want to use the times 10 unless I need to zoom into a signal and look at it in time, zoomed in. So it says here pushed in, on. Pushed out, you see here it's longer depth of the switch is taken to the outside, so it's pushed out. So I took the magnification, times 10 magnification in the time axis off, okay? Now, I still don't see a horizontal line. So let's see, something is called the triggering. Vertical, auto mode. هلا بنحكي عنهم كلياتهم source channel 1. هلا بنحكي عنهم كلهم بس لأنا حتى لكم كيف عم جيب الهوريزونتال لاين. اوكي. إذا سمير ما قدر يجيب الفوكس لاين يعني الله يعين التلاميذ. الهوريزونتال لاين قصدي. So why it's stuck? I think we are in some XY mode. هيدا زر اسمه XY mode. هذه مود متطورة. بنطبع voltage versus voltage مثل V versus I for the diode characteristic. So when I saw a dot, I remembered from long time experience that I am in the XY mode. So this button was pushed in on, and I am in XY mode. يعني I'm plotting this voltage of channel 1 against this voltage of channel 2. لاحظوا هون مسميينه Y مع انه انا كنت مسمي اول واحد channel 1 X والثاني Y، بس هو حسب البلوت يمكن هيدا channel بيرفع البيم upward مش هيك سموه Y، وهيدا channel بياخد البيم horizontally so سموه X. So we're not going to learn XY today, so I had to turn off this XY. Now I see my horizontal line, okay? The first thing you want to do is I'm dealing with a transformer that is going to put out, we learned the simulation of this rectifier to be around 10 volt. And we bought intentionally transformers. Let's talk a little bit about this transformer. It has 0 in, 220 in, so they say primary is 220 and 0, and then you use 2 wires called red احني هون red وred طالعين من the transformer. It's 15 volt amp, okay? So if the output is 7.5 between 0 and 7.5 here, so I can or from this, it has a center tap called the black, you see here BLK, okay? The 0 center tap is 0 volt. On the left, it's 7.5 blue. This is the blue. On the right is 7.5 blue. This is the right blue. From blue to blue is the summation of 7.5 with respect to 0 and another 7.5 from 0 to 7.5. That's a total of 15. So 15 divided by 15 amp, 15 volt divided by 15, 15 volt amp divided by 15 volt is 1 ampere. So I can draw out of any one of the windings 1 ampere max, okay? Now out of the 1/2 of primary, secondary عفوا, هون كاتبين SEC يعني secondary, I have 7.5 volt times 1 amp is 7.5 volt amps. So volt amps is like power, voltage times current. Now why in AC we use volt amperes is because there may be some power factor وفي apparent power و real power. ما حنفوت بالelectric circuit هون. هلا نحن بنعرف انه هيدا الريدنج ان كانت 220 ولا 7.5 على الاوتبوت هني RMS values. يعني to get the peak of the output هون we have to multiply 7.5 by square root of 2, we get around 10.6 volt peak, okay, out of each secondary halves. Now this is the transformer. We connected for you a connector that has usually is meant to be soldered on a printed circuit board, okay? And we call this a junction where we can join a wire into this terminal. Terminal is also a proper term for it. Let's talk about the breadboard. You've seen it in Tinkercad. The top wire is blue, is connected all the way from left to right, and they have it minus labeled here. So you put if you want the ground of a DC source, but we're not building a DC source, we don't have a DC source to tap to or to connect to, we're gonna generate DC. And then the bottom wire is all connected, ما في interruption بالنص. عادة إذا قطشوا الريد واير هون يعني بدك تعمل جمبر من هون لهون، بس واصلين ليهم كلهم من جوا. سو في عنا ريد باس يعني البوزيتيف. كمان نفس الشيء تحت عنا كل هيدا الرو ماينس all the way from left to right. فيك تحطوا polarity تاني، مثلا هون ground و plus 5، هون فيكم تحطوا ground و plus 12. او نفس ال plus 5 تحطوها تحت وفوق. امتى ما بدكم اياها بتوصلوا عليها اذا عم تركبوا digital circuit. So all this way is in common, Now each one of those 5 columns are in common مثل ما درسنا بالتنكركاد. So حطينا junction على ال first 3 columns اللي هن made of 5 holes or 5 nodes, okay? So we connected, and notice there's a space. So because when I plug this in, I'm not gonna see, I have to see before I plug in the left column of 5 points labeled A, B, C, D, E here, okay, are in common vertically. I connected my left to blue. The center tap, I have to skip one to reach my center tap because the pins here are spaced 0.2 inch لأنه كل هيدي spacing between هيدي الهول وهيدي الهول in كان vertically or horizontally is 0.1 inch American standard. So I have 3 wires and I know where they're located. Basically, if you look at these numbers, it's 1, 3, and 5. So this is plugged in on 1, 3, and 5, but they only label 1, 5, 10. So you know which column it is. It's column 1, 3, and 5. So this is my AC in. Back to the scope now. هلا نحن قلنا البروب باثنيناتهم حنحطه على التايمز 1. هيدا سلايدر على التايمز 1 على الشمال، في تايمز 1 هون صغيره، وبدي اتاكد اثنيناتهم على التايمز 1. سو اثنيناتهم الاورنج سلايدر سويتش is on times 1. هلا هيدا عنده هوكس. في ناس بدهم يفحصوا بدون ما يعملوا هوكينج على كومبوننت، مثلا سيرفيس ماونت كومبوننتس بنسميهم SMD، بنشيل هيدي التيب وبصير بنفحص PCB different points اللي ما عندهم ريزست مثل الريزسترز هدول اللي مركبينها هون، مثل الدايود ما عندهم ليدز، هن سيرفيس ماونت. بنبقى بنورجيكم صوره على سيرفيس ماونت كومبوننتس. في عندنا هون VGA بورد بس ما موجوده على الطاوله انس لنورجيهم SMD، ما بيأثر. طيب don't remove this, leave it, but remember you have to, after you screw it on the head of the probe or tip of the probe, you push it down, then the hook appears, and then you can hook it on anything you want to measure. It has to have leads, of course. نرجع للأوسيلوسكوب. فإذا قدرنا بالانتنسيتي نحطها على الآخر، والفوكس هلا كيف لكن لما بكون out of focus بصير الخط الرفيع بصير عريض بالثيكنس بالفيرتيكال direction. So you have to focus it to be the thinnest possible. You have to focus it to be the thinnest possible. مثل بيعمل فوكسينج على البروجيكتور على الوايت سكرين. هلا نحن عم نقيس فولتاجات بال 10 فولت. سو بنحط عندنا دائما 10 ديفيجنز هون 1 2 3 5 اوكي. فينا نحطه على ال1 لانه نحن عندنا سيجنال that is minus 10 ما بيمشي الحال. So إذا بحطه على 2 volt per division, minus 10 appears here, it goes down, minus 2, minus 4, minus 6, minus 8 عفوا. لكن أنا في سكوبات معود عليهم عندهم 10 division، هذا عنده بس 8، 1 2 3 4 5 6 7 8 divisions. هذا دقة قديمة كتير. لانه ستاندردز النيور سكوبس حتى لو كانوا انالوج اولد جنريشن بيكون عندهم 10، هلا عنده 4. طيب ايه بالهوريزونتال عنده 10 سب ديفيجن 10 ديفيجنز ميجر ديفيجنز 10 1 2 3 4 5 6 7 8 9 10 ماشي. هلا فاذا هيدا الفيرتيكال بوزيشن عم غير اللاين ليكون على نص السكرين، حتى الماينس 10 هلا ما حتبين معي هون اوكي، وحنتاكد من هالشيء لما بنحط على السيجنال. هذا الترانس اوريدي عملنا لكم واير لكم وعاملين له بروتكشن هون مشان ما تكهربوا من جهه ال 220 وبتشكوه بال 220 سورس اوكي، وحيعطينا لو فولتج. هدول اللو فولتجز حتى اب تو 50 لو مسكتهم حتى الاولاد الصغار ما بيكهربوا اب تو 50. يمكن هلا السنتين يمكن يحسوا بالتينكلينج شو بعرفني على ال 50 فولت، بس انا بضمن لكم انه ال 50 فولت ما بتحسوا فيها، ما بتشعروا الا اذا ايديكم مجروحين ومبللين مي. هلا خلصنا انتنسيتي، خلصنا فوكس، خلصنا بوزيشن. هلا 2 فولت يمكن السيجنال تحت قلنا اذا كان نيجاتيف او تطلع بوزيتيف تعمل بيكينج، ساعتها بدنا نضطر ننزل على ال 5 فولت بير ديفيجن. يعني هون ال 10 حتطلع بس 2 ديفيجنز، بلس 10 بتوصل لفوق والماينس 10 بتوصل لهون اوكي. خلينا هلا نحكي عن الفولت بير ديفيجن. واضح ببلش هون 5 فولت اذا كنا على التايمز 1 بيكون 5، اذا كنا على التايمز 10 البروب بصير بده يضرب كل رقم من هدول ب 10، لانه هيدا قسم 10 فبصير هون بتخيلوا انا هذا كانه 50 فولت بير ديفيجن لما احط التايمز 10 بالبروب اوكي. سو بصير هذا 50 فولت. هلا لانه انا حاطط على التايمز 1 هي 5 فولت بير ديفيجن بالفيرتيكال دايركشن بالواي اكسس. هلا هيدا النوب على بعدنا بالانبوت تشانل 1 اذا بتحطوا جراوند البروب لو حاطه على سيجنال ما بتشوفها هون، يعني انترنالي بيعمل شورت سيركت بس مش على السورس طبعا، بس انترنالي بيفصل السورس عن الاوسيلوسكوب سيركتري سنسينج سيركتري، والسنسينج سيركتري بيحط لها الانبوت تبعها على الجراوند لحتى تقدر تشوف هون هوريزونتال لاين وتعمل فوكس مثل ما بدك. اذا بدنا نقيس سيجنال حتى لو كانت اي سي، بس اذا كانت اي سي وفي embedded on top of DC بنحط الcoupling between the scope circuitry sensing circuitry and the probe itself بنحطه على DC coupling. شو يعني DC coupling؟ يعني اذا انا فايت عندي سيجنال وبقلبها دي سي I want to see this DC on the screen، وهلا لما بنرجي سيجنالز حنفهم الفرق بين الدي سي والاي سي. بس انا بذكر تلاميذ الالكترونكس لانه صرتوا بمرحله advanced more than the electric circuit, you already finished the electric circuit. When you go to AC الاوسيلوسكوب بحط capacitor in series with the input signal، يعني الدي سي ما بيمرق بالكاباسيتور. One of the electronics applications of a capacitor is to block the DC and allow بس the AC to go through. ليش بنحتاج نعمل هيك؟ حنحكي عنها لما بدنا نقيس الريبل اوكي بريكتيفايد سيجنال. فاذا خلينا هلا على الدي سي both channels، خلينا على ال 5 فولت for both channels، بس انا هلا بدي اشوف الشانل الثاني. هيدا بحدد الفيرتيكال which channel you're plotting okay. If I go to channel 2 okay then عم بيشتغل بالعكس. هيدا لاحظوا انه انا عم ببرم على اليمين وعم ينزل نزول، يعني في شيء inversion مكبوس هون. هلا تعلمنا channel 2 can be inverted. Why would I want to invert the channel 2? Because I may plot a channel 1 minus channel 2. When I go to add here, it adds the signal of channel 1 with the signal of channel 2. But if you invert the channel 2, يعني you're doing subtraction. So the inversion is to be able to, when you push it on, is to be able to subtract the channel 1 2 from channel 1 or channel 1 minus a channel 2. So you go to add and you invert channel 2. ساعتها بتشوف the difference between two signals. Some measurements require you to measure the difference between signals. يعني عندي مثلا أنا resistor مارق فيها signal وبدي أقيس الفولتج across it. هلا أنا قست الفولتج على الشمال 9 وقست الفولتج على الشمال لنقول 10 وعلى اليمين 9. طب أنا بدي أحسب قديش الفولتج difference across the element. بعمل VA minus VB بيطلع معي 1 فولت مثل هلا الفولتج across the diode. I can measure it okay with two channels, one on the left, one on the right, and tell it to subtract, so I will be able to look at the voltage across the diode مثلا as a good example to use, add the channels, but then when you push this, subtract 2 from 1. I'm looking at channel 2 by itself. I want to basically center it on the center line here, the x-axis or the time axis. If I go to alternate or chop, basically I'm displaying channel 1. When I finish the scope plotting channel 1, it goes to plot channel 2. Chopping means plot a little bit from channel 1 and a little bit from channel 2. So it's chopped, the signal is chopped, the plotting is done, a piece from channel 1, a piece from channel 2. A piece from channel 1, at high frequencies, chopping may be more stable screen than the alternating, okay? So you will know when, depending on the frequency of the signals, which one is best for you. Just try the one that gives you a clearer view on the oscilloscope screen. It will be the better choice. But the only way to see both channels 1 and 2 is to go to alternate or chop. Okay. Now both of them, 1 and 2, are centered perfectly horizontally on the center line. There's nothing to prevent you, if you're looking at positive pulses, to bring your reference to be either the bottom line or the one above it. It doesn't always have to be the center line, especially if you're measuring positive pulses that can go up to 8 volts and you go to 1 volt per division لحتى make a more accurate measurement, and we will see an example soon. So now we've covered the vertical mode to be able to plot channel 1 by itself, channel 2 by itself, or alternate between both channels, or chop between both channels, or do an addition on both signals or subtraction. وهيدا symmetrical مثل هيدا حاطينهم اثنيناتهم هلا على الدي سي واثنيناتهم على 5 volt per division. You can have a different voltage per division on one channel, but you have to know what you're doing, and you always look at your volt per division scale. And the last knob I want to talk about here is always maintain this variable on calibration position. Why? Because this 5 volt per division or 2 volt per division wouldn't be accurate if this knob is not on the calibrated position. اللي هي all the way clockwise. Both channels should be clockwise. Similarly, we have a calibration variable on the time control. Sweep يعني go from left to right as it's plotting with the electron beam, this signal left to right, but its plotting is so fast I'm not able to see the line. But when I slow it down, I see the dot. Okay, this is how fast it's plotting, and also determine the frequency of the signal. If you have a slow frequency, you have to go to a bigger division per scale. يعني هون 50 millisecond per division. It's a sweep time per division. So how long is taking it to cross from one of those vertical lines to the next lines? 50 milliseconds. So the period has to be long and the frequency has to be low to be able to use these relatively speaking large time millisecond per division. I'm increasing the speed, so it's sweeping faster, and I don't see it flickering anymore because my eye cannot see the dot, but the recording is still showing because the camera has a 30 frame per second or 60 frame per second. So there will be stroboscope effect, and I'm not going to go into that. The physics talks about it. So we also set the variable of the horizontal, which is time position, time scaling, and you understood here it's time per division. This is on calibration. We turn off the magnification, otherwise we don't need to zoom into our signal, so we have to keep it to the outside. Longer length of the push button mean it's off. هلا عندنا هذا الهوريزونتال بوزيشن. لاحظوا البوزيشن هون رسمين سهم يمين شمال. هون كان البوزيشن فيرتيكال، طلوع نزول السهم تبعه. سو انا فيني بلش البلوتينج محل ما بدي. عاده انا دائما بحط البلوتينج يبلش من اول خط الفيرتيكال على الشمال، الواي اكسيس يعني. اوكي؟ ببلش البلوتينج من هون لحتى اشوف قد ما فيني من السيجنال من هالنقطه وبالرايح. وكمان اذا كان الساينوسويد بحب تبلش الساينوسويد من الواي اكسيس اللي شايفه انا على الشمال هلا. طيب عندي هذا channel 1، حروح على channel 1 وبدي احطه في عندنا هون اسمه شيء اسمه calibration. It gives us 1 volt peak to peak signal at 1 kilohertz. So I attach, before I test my circuit, I attach my probe to it. I go to 1 volt per division. I'm using only channel 1, and I go to a smaller time subdivision or time per division. هلا بلاحظ انه my signal is horizontally scrolling to the left. It's not stable. So now we have to talk about something that confuses most people. Okay, it's called the triggering. The scope has to start plotting at a point of your signal. Okay, imagine the triggering. You have a horizontal line here. It's called the triggering level. Okay, it's a horizontal line, but in these all the scopes, it wouldn't show it to us. We have to imagine it as a horizontal line, and there's going to be crossing between it and our signal. This horizontal line cannot go below this time axis and cannot be above the highest peak of the signal, which is 1 volt peak right now, as they indicated here. It's 1 volt peak to peak. So the imaginary line has to be between 0 and 1 volt in order to cross my signal. So I'm going to play with it. Okay, as soon as it became between the minimum of the signal and the maximum of the signal, there's an intersection. Okay, there's يعني شو بنسموه common point between the horizontal line اللي هو imaginary now. Some advanced scopes, digital scopes, will show it to you as you move this knob. They will show either an arrow on the left, or they show a horizontal line and then it disappears, and they make it usually dashed line or whatever. Now you can start plotting from either the negative slope when this is pushed, or you take it to the outside, start plotting from the positive slope. لاحظوا هلا انا البوزيتيف سلوب طالع من الزيرو للهاي، بس ما بشوفه لهيدا اللاين كثير لانه كثير سريع بالطلعه، يعني it's very dim, and I don't know if the camera, is showing it when I removed my finger. So it's plotting from the positive slope of my signal. If I want to start with the negative slope, I push it in, it start plotting from as it's going down from 1 down to 0. So now we understand the level knob of triggering. We understand if we want to start plotting from the positive or the negative edge. هلا في عندي هون 2 buttons also belonging in the triggering group of the oscilloscope. هدول تقريبا اخر 2 buttons حنحكي عنهم. السورس الoscilloscope has to listen either to channel 1 to do the triggering. لما نقول triggering يعني when to start plotting اللي هو intersect between an imaginary horizontal line and the signal itself. You can either trigger off of channel 1 or off of channel 2, or هلا هون كان vertical mode. اوكي هون channel 1 هون channel 2. صراحه الفيرتيكال مود انه انا هون حاطط channel 1، هيدا الفيرتيكال مود، يعني اذا انا حاطه هون على channel 1 هو بياخذ حسب انا اي عم بعمل له بلوت. هلا انا على channel 2 ما مفوت سيجنال، حفوت نفس السيجنال. اوكي I hook it up in this hole and I set it to 1 volt per division. بعد وحده. Thank you Anas. And now I'm triggering on it. هلا لاحظوا انه triggering of channel 2، والدليل انه بشيل channel 1 من هون بعدها stable signal. ليه؟ لانه انا حاطه على، تعال شوف من هون vertical mode. Source is vertical mode and the vertical mode is set on channel 2. So it's getting, I'm plotting channel 2 and the triggering system inside the scope is getting triggered on the same selection you have on the vertical mode. هلا if I trigger of channel 1 ما في signal فايته على channel 1، ما حيعمل، ما حيهدى horizontally، حيضل يعمل scrolling. بس اذا برجع بفوت السيجنال على channel 1 حيعمل triggering عليها، لانه قايل له انا تسمع على channel 1. هلا جابره يتسمع على channel 1 regardless of what I'm plotting. I'm plotting alone channel 2. هلا نفس السيجنال ما حتلاقوا فرق بيناتهم، بس I can when we start plotting the half the rectifier we're going to see 2 different signals, the input signal and the output signal. So triggering, most of the time I trigger off a channel 1 and I usually plot my input to the circuitry that I'm analyzing with the scope. I plot the input on channel 1 and I plot the output on channel 2 حتى ما ضيع which is which. So دائما نحن بنبلش بالسكيماتكس left to right، also بنفوت السيجنال على السكوب حتى ما نضيع. الشانل 1 بنحطه هو الانبوت سيجنال، والشانل 2 على الاوتبوت سيجنال اللي بدنا نفحصها مثلا على اللود ريزيستور. تقريبا هلا صار عندنا فكره على سكوب، خلينا نبلش نستعمله على السيركت. هلا السيركت basically I plugged in Anas did مشكور he plugged in a diode من هيدي ال AC signal من هدول ال 5 nodes كلهم in common. لما بيشك بهيدا الهول اللي هو نحن اذا موقفينه هيك بيعتبر column 1. اوكي سو شك على هيدي النود يعني in common مع البلو، وحط الكاثود يعني هو البوزيتيف اوتبوت لانه البوزيتيف alternation بتفوت بالانود، وهيدا الشحطه هي الكاثود بيطلع منها البوزيتيف كارنت convention current flow، واخذ السنتر تاب ووصلها على البلو بس or group of lines اللي هو النيجاتيف، لانه السنتر تاب هي النيجاتيف. هلا عندنا بس one diode being used يعني half wave rectification على 10 فولت 0.6 بيك اللي جاي من هون، بس هي بلس ماينس 10.6. اوكي بلس ماينس 10.6 وهلا حنشوفها. اول شيء حاعمله حاخذ هيدا channel 1 وححطه، بدي احطه على الجراوند. لاحظوا وين اللود ريزيستور، هيدي الريزيستور is like at least like 5 watt. God knows we couldn't really tell for sure, but it's a much larger resistor. Usually small resistors are as big as this diode. So this is more wattage resistor. It can dissipate heat more. It can handle more power dissipated in it, and it dissipates it to the environment, to the air. Now we took the load resistor, connected it to the cathode, the half wave rectifier output, and we connected it. This entire line here is in common. We connected it to ground. So now the current is flowing. Positive pulse goes into the anode, out of the cathode, into the resistor, into this blue blind. The current continue convention current flow into this black wire, and it goes back to this center tap black wire on this hole. So I have a half wave rectifier with no filtering. So now the scope has 2 pins. Basically, the ground is connected to the shield so that this scope will measure only the signal of interest under test. So we put this shield wire on the ground of our circuit, and we put the tip hook on the sinusoid. So now if I plot channel 1, I have a sinusoid, and I can see I'm exceeding my volt per division. So I have to go to مثل ما قلنا من قبل 5 volt per division. Okay, but let me check my ground here and here. I have to turn on both of them, and I set them both to ground and verify my position. Now it's on alternating. This is my vertical position. They have to be superposed on top of each other on the time axes. وهذا البوزيشن تبع channel 2 كمان فوق بعضهم. وهلا الهوريزونتال بوزيشن باخده ليبلش exactly من اللفت. هلا حدور channel 1. هاي first half cycle مش مبلشه exactly على زيرو بس مقبوله. ليه؟ لانه الليفل فيني العب فيه الليفل knob. I can modify it to cross this signal exactly at 0, so the sinusoid start plotting at 0, but when I raise it up, it's gonna delay. I have a horizontal line that I raised it up, and it's making intersection at 2.5 volts now, because I have 5 volt per division. So that's why the sinusoid is not starting plotting at 0, because I raised my triggering level line to 2.5, and the intersection happened at 2.5. I bring it back to the center, almost Hanifi point, to make, but I look at the screen and I need a better focus now. Okay, it is still focused, but this is the nature of the beast. This is a 50 hertz signal, and it's not going to be focused. These are old scopes. Notice here it's focused, but here it's not focused. And make sure magnification is not on. Because if magnification is on, notice how slow is the plotting of this signal, and it becomes very annoying. So you have to turn off the magnification, and you can go to a higher per division. Remember, this is 50 hertz. So it is set at 2 millisecond, and I have from 0 to 0, I have 10 times 2 millisecond. That's the 20 millisecond, which is the inverse of 50 hertz. 20 millisecond, 2 per division, and I have total of 10 division from 0 to 0. So I'm plotting one cycle only. I have a 2 millisecond per division, and this is how you make your frequency measurement. You count the period squares, and you know each horizontal major division is 2 millisecond times 10 is 20 millisecond. You take the inverse, you know the frequency is 50 hertz. Now, why this is not pure sine wave is because the loads in the university are electronics loads, the power supply of the PCs mainly. They are not resistive loads. They have bridge and capacitor just like this, and the current peaks only at the peak, and this is what create distortion on the signal coming out of the generator or the power that is coming out. It's a voltage signal anyway. And this is all due to not having pure resistive loads. And the current is not sinusoidal, just like the voltage is. So, how long the recording so far?
34.
34. الله أكبر. يعني صرنا على الآخر تقريبا. هلا نحن الانبوت signal is sinusoidal. We're gonna connect our second channel, ground to ground, shield to ground, and we're gonna watch the output after the diode half rectified. But I have to turn on. Now I go to DC, okay? This is need to go to same subdivision to be comparable to each other. بيقولوا الأمريكان comparable. هلا في flickering و magnification is turned off. I cannot do better than that. مع إنه من شوي أنا وأنس يمكن لما رحنا أجينا let's go to chopping. You see, alternating is flickering because it plots one and it finishes it and then it starts plotting the second. That's why you see them rippling, because the curve has to be plotted after the first one is finished. But when I plot it in chops, in small pieces, then they look lesser flickering. But high frequencies may not be the case, okay? Now, obviously, I have a voltage drop here on the output of the diode because it's losing قلنا على 1 amp 1 volt. بس نحن هيدا اللود resistor تبعنا 91 ohm and it's gonna draw a little bit more than 0.1 amp لأنه حتى إذا بتلاحظوا الأوتبوت هون is more than 10 volts. حأطفي 2 ونركز على 1. أنا الأوتبوت تبعي مش بس 10.6 لأنه عندي 5 فولت per division، يعني طالع لي يمكن الكهرباء اللي جاي منا 220 يمكن جاي 230. المهم هلا البيك تبع الترانسفورمر is more than 10 لأنه 2 divisions are 10 لأنه عندي times 5. عندي هون تقريبا إذا بدي قيس بدي زيحه horizontally على محل ما في تكس هون. اوكي شو يعني تكس؟ يعني هون شحطات صغار، في عندي 1 2 3 4 5 minor divisions. كل واحد منهم هدول التكس is whatever the subdivision divided by 5. يعني كل واحد من هدول 1 volt. So when I move the peak of my signal, it is taking 1 subdivision and I have 5 volt per division, so it's 1 volt. So it's 11 volt peak. This is how I make my measurement. Again, I repeat, I have 5 volt per division. So I have 1 division 5, another division 10, and then 1 subdivision and a little bit. But I'm gonna ignore this little bit and I'm gonna assume 1 subdivision out of 5 لأنه هيدا الديفيجن الكبير مقسوم ل 5 subdivisions. So 1 tick is 11 12 13 14 15. يعني لما برجع بوصل على ثالث division بيكون عندي 15 volts. So my peak is 11. هلا when I make voltage measurements, I'd like to bring sorry my signal peak to this center line because the subdivisions تاعوله مرسومين. اما الفيرتيكال لاينز الباقيين ما عندهم هدول السبديفيجنز اللي موجودين على هذا السنتر vertical line. Okay, so I made my input peak voltage. Now my channel 2, okay, is ما نزل من ال 11 exactly لل 10. So ما عندي 1 volt drop. Okay, I want to measure this more precisely. Before we do the measurement of across the diode precisely, let's talk about what happens if I move this to AC. هلا هيدي السيجنال نحن بنسميها لحتى نرجي اثنين منهم، بنرجيها هيدي pulsating positive signal لأنه الدايود مرق بس الupper half of the sinusoid. الافريج تبعها هو تقريبا هون، يعني عندها افريج خط هون الupper area قد اللور area لازم تكون، يعني the average is the line where the upper areas match in size to the lower areas below the line. When I move this to AC coupling, الأوسيلوسكوب في capacitor in series مع الانبوت signal now. It basically eliminated the DC average from the signal, and now the signal is symmetrical around my zero line. لما بروح على الجراوند عندي هذا الزيرو لاين حاطه انا مسنتره على الميدل horizontal line. It took out the DC, so now the bottom area here below is equal to the upper area above. So the average of this DC pulsating signal is taken out and I'm seeing it balanced. Now, it doesn't help me here to go to AC, okay? But if I'm measuring ripple, okay, peak to peak, it might help me to go to AC and I see only the AC on top of the DC. يعني أنا عندي مثلا عندي line average تبعه 9 فولت وعم بيطلع بس 0.5 وبينزل minus 0.5. So أنا ما بيهتم بال9، أنا بدي أقيس البيك تو بيك ريبل، يعني بس بدي أشوف ال AC on top of DC. Let me cancel the DC and my AC signal will be brought down. This is not the purpose of it. Now I can go to a smaller subdivision and increase the ripple size on the screen and be able to measure it more exactly. يعني هلا to see them both, okay, I want to measure the voltage diode drop using subtraction between two signals, okay? مش أنا حاطط probe 1 على الشمال وحاطط probe 2 على اليمين, okay? Let's plot them together. Okay, I can go to add, I can go invert 2. So it's subtracting 2 from 1. And what does that tell me?
Negative cycle.
I have this horizontal line here, okay, is minus 1 volt تقريبا بس أقل بشوي يعني شي 0.7 بدي أشوفه أحسن. أو خليني أشوف التو بيكس وقيس الديفرنس بيناتهم. This is one way. Go back to both channels. Don't invert the second one. I wanna see, so I'm gonna bring my zero to the lowest possible. I'm gonna bring my zero to the lowest possible. هيدا أول channel زيرو نزل لتحت تحت. وهيدا التاني channel قاعد فوق منه بالضبط على أوطى horizontal line. Okay. Now, كتير sensitive. Now I go to DC, but I increase, I should have centered, I increase to 2 volt per division, 1 volt per division برات السكرين وهيدا 2 volt per division. Okay, but let me double check my horizontal is still centered around the bottom horizontal line. Vertical position, one channel at a time is better. This is one channel. Okay, I went to channel 1 plotting alone in vertical mode. Okay, I see the black wire, the black horizontal line is in the center of my thick green illuminated scan, and then I go to channel 2 and then adjust its position. This is how you need to make precision measurement in the old style analog scope. Now I turn them both on. I have to plot them both by going to chopping. Now I have two subdivisions, difference between the two peaks. Two subdivisions, okay? ونحن قلنا ال1 division مقسومة على 5. هلا أنا عندي 2 volt per division هون وهون. So 2 divided by 5 is
0.4.
is 0.4. 0.4 لكل subdivision. Times 2 لأنه عندي 2 subticks here between them. Times 2 is 0.8. So this diode is dropping only around 0.8. It's probably 0.7. بس نحن my measurement is coarse. My voltage drop across this diode is approximately 0.8 with this scope measurement. لأنه الكرنت اللي ماري فيه للدايود is قلنا البيك تبعها هيدي 11 after the diode. It was now 2 volt per division. فينا نقيس نرجع البيكس more precisely. 2, 4, 6, 8, 10 and 1 volt here. It's almost halfway, so it's قديش طلعتي أنا سمعنا؟
11 وشوي.
11 وشوي. 2, 4, 8, 10 عفوا 2, 4, 8, 10, 12. ليش عم نعد غلط؟ الزيرو تحت هي 2, 4, 6, 8, 10
Yes.
and half of it is 11 volt and a little bit more. اعتبروها 11. After the diode is 11.3 تقريبا لأنه أوطى من السبتك اللي هي 0.4. So 11.3 divided by 91 ohm حيطلع اكثر بشوي من ال 0.1 amperes. Okay. That's why the diode didn't drop 1 volt لانه كنا بالسيميوليشن نحن عم نعمل دروب عليه ل 1 ampere فاخذ 1 volt على 1 ampere according to the data sheet. So basically this is how we measured the difference. But let's suppose we want to measure ripple now. If I insert this 100 في عنا 1000 هون.
الكبير.
الكبير
لا الوسط.
الوسط. Okay, makes sense. So بدي احطه parallel مع اللود. هلا في عندي هيدي النود فري وهذا النيجاتيف تبع الكاباسيتور بحطه على البلو.
بينت.
شو بين؟
على الشاشة.
هلا بينت عندي السيجنال is charging during the positive alternation and discharging in between. This is half wave rectifier. Notice the current of the charging is distorted my input sinusoid. It's not perfectly sinusoid anymore. This is real world because the secondary here has a resistance due to the winding, you know, copper winding is thin. It's not very thick. It has, everything has internal resistance. هلا بدي اقيس البيك تو بيك ريبل. اوكي لاقيس بيك تو بيك ريبل بدي انزل للور سب ديفيجن لاقيسها اكيوريتلي يعني حركز على تشانل 2 انا وبدي اقيس البيك تو بيك ريبل. هلا على 2 فولت بير ديفيجن ما حقيسها كثير اكيوريتلي. اول شغله بدي اعملها بدي اشيل الدي سي لحتى لما بروح على سمولر سب ديفيجن اختفت بصير بدي اعمل لها انا وبدي انزلها للسنتر لاين مش عم بقدر انزلها. هلا فيني اقيسها هون بس بركي بدي انزل كمان اكثر. هلا كل ما صغر الفولت ما بقى فيني ارجع انزلها صارت برات السكرين. شو بدي اعمل؟ بدي اشيل الدي سي منها. لاحظوا لما كنا هون اذا بنصفر هيدا اوكي هيدا اوطى شيء لما بنحط على الدي سي عليت اوكي بدي اشيل هيدا الدي سي من السيجنال وركز بس على الاي سي اون توب اوف دي سي. قديش هو الدي سي؟ هو الافريج سيجنال قلنا with respect to zero هو هون الزيرو تحت. الافريج دي سي is the horizontal line between the minimum and the maximum. بحط الاوسيلوسكوب اول شيء bring this to the center. Zero line bring it to the center. Okay. Now go to AC. لاحظوا هلا DC was eliminated because we inserted internally a capacitor in series with the signal. The DC is eliminated. Only the AC passed through the capacitor. هلا قد ما بدي بصغر الفولت بير ديفيجن وبقيسها very accurately قديش هي معي البيك تو بيك سيجنال. هلا انا فيني لما بقيس بيك تو بيك فيني العب هون طلع السيجنال اللي تبلش على 1 هوريزونتال لاين بس ما بطلعه كثير. اذا فيني طلعه للسنتر اكسيس اور تايم اكسيس. هلا بزيحها هوريزونتالي ليصير عندي البيك على الميدل فيرتيكال لاين. صار عندي قديش الفولت بير ديفيجن؟ هاف ا فولت 0.5 1 and a half and almost middle way so it's 1.75 لانه كل سب ديفيجن هاف من هون عرفتها هيدي الهاف فولت بير ديفيجن. انا عم بقيس على شانل 2 اللي هو اللود. شانل 1 هي سورس سيجنال قبل الريكتيفاير. سو كل سب ديفيجن 0.5 هي هون وانا عم قيس اكزاكتلي وهدول بده يكونوا كلهم على الكال ليكونوا الفولتج والتايم سكيلز مزبوطين. So half, 1 and a half and a quarter. So 1.75 volt is my peak to peak ripple. Okay? This is the end of how to make measurements with this scope. Sorry, I could spend maybe 30 more minutes to give you more detail. I had to squeeze it as fast as possible because you guys get bored from me very soon. And you have to watch this probably a couple times and pause and apply what I teach you to get the benefit of learning how to use a scope. Thank you guys for your attention.